So for example E, we're going to start by putting this augmented matrix into our calculators. In fact, we've already done that. So let's take a quick look here. There's our matrix. Now, in general, if you're going to actually solve this, not just do a quick couple manipulations here or there, if you're actually going to solve this system of equations by back substitution like we did for problem B, when we had it in this nice form where we already had zeros here, here, and here, then we're going to want to get zeros in these spots ourselves. Now, let me make a suggestion. You want to get zeros in this order. You want this one to be a 0, this one to be 0, and then this one. So 1, 2, and then 3. So use row 1 to get zeros in the places of 1 and 2. Use row 1 to get zeros at places 1 and 2. So that's what you're going to start out with. Then you're going to use row 2 to get a 0 in place 3. Then use row 2 to get a 0 in place 3. So you want to get the zeros in that order. Now, if you don't trust me on some of that, then if you play around often enough, you'll figure out that, oh, if you try to get a 0 here by using this row, then you're going to lose your 0 there. So trust me on that one. I've done a lot of these things.
Should we do 2 times row 1?
Actually, let's go into program row ops and let me show you what I would do with a problem like this. So enter program, and then press enter until you get to program row ops. Press enter again. Press enter again. And then let's select matrix A. Now what I would do, trying to do the path of least resistance, I want to get a 0 here. I can get a 0 there if I swap the first 2 rows, right? If I just interchange row 1 and row 2, great, So if you press the enter key here, it gives you these options, and one of them is to do a row swap. So okay, let's swap row 1 with row 2. Great. I got a 0 exactly where I expected it. And now what? Now I want to get a 0 where that number 4 is. So Genevieve, what could I do to get a 0 where that 4 is? Is there anything I can multiply the first row by and add to the third row? -2 or +2? +2. Good. So if you press enter, then I want to choose the 4th option, which is multiply row add. Multiply row 1 by 2 and add it to row 4. And I think we get a little bit of a bonus in this one.
Where would be row 3?
Yeah, row 3, thank you.
Oh.
Yeah, thank you. Yeah. If you do make a mistake and all of a sudden you find yourself in the program, row ops by mistake, just hit the 2nd key and then the mode key to quit right away. You don't want to accidentally enter or edit that program. It'll mess it up.
I messed it up.
You already messed it up? Okay. I'm going to have to reload the program for you.
I don't know if I did something, but...
Program. It's still working.
Oh.
Yeah. So we're looking good here, right? I mean, take a look at what this system of equations represent. You've got a nice augmented matrix that's in that upper triangular form. So, wow. Let's use this to kind of solve our system of equations. What does that system of equations actually represent? Well, let's take a look here. Might help if I switch over like this. Actually, example E. My new matrix, after I worked with it, let's see, I did 2 operations, right? I did First of all, I did a row swap, which is row 1 and row 2 were interchanged. And then I multiplied 2 times row 1 added to row 3, and then that gave me this matrix right here. Negative 2, 1, 2, 1, 0, 2, 4, and 1, 0, 0, 4, and 2. That's nice. This is that upper triangular kind of form that I've mentioned. You've got a nice triangle of zeros right here. Let's go back and rewrite this as a system of equations. What does this mean in terms of x's, y's, and z's? How about the bottom equation? That'd be 4z equals 2. And then 2y plus 4z equals 1. And negative 2x plus y plus 2z equals 1. Now I claim that it's nice to have it in this form. It is. It's real nice to have it in this form. In fact, what can you tell me about any of my variables now that we have it in this form?
Z equals 0.5.
Yeah, z equals 2 divided by 4 or 1/2 or 0.5. Great. There's one of your solutions. Gavin, what can I do to get another solution? Yeah, let's take this value for z and plug it in here. Thank you so much. So it's going to be 2 times y plus 4 times 1/2 equals 1. So let me put that 1/2 in here. Four times 1/2 is 2. So it's going to be 2y plus 2 equals 1. So y equals negative 1/2. Okay. 2 down, 1 to go. What am I going to do to get that last one? Yeah. Take both of these values and put it in the top equation. Thank you so much. So negative 2x plus negative 1/2 plus 2 times 1/2 equals 1. So negative 1/2 and 1. So that's going to be 2x minus 1/2 plus 2 equals 1. What was that?
Negative 2x.
Oh, negative 2x. Thank you. Thank you. So let's think.
Z doesn't equal 1, Z equals 1.
Oh, z 2 times. Yeah, there we go. I was looking at that going, wait a minute, something feels wrong. Thank you. So that should be a 1/2 here, and then 2 times 1/2 is 1. So let's make a 1 here. And I guess what I'll do, just out of giggles and out of convenience, I'll subtract the 1 on both sides because that's pretty easy, right? You're just 2x minus 1/2 equals 0. Negative 2x equals 1/2. And right here, a lot of you might get a little bit flustered because you're like, oh, I got to divide 1/2 by negative 2. And I get it. Let me make a... What's that? Yeah, well done. But if you're not really all that comfortable with fractions, let me suggest a slightly different approach. If you don't want to divide the fractions, you can multiply both sides by the reciprocal of negative 2. So negative 1 over 2 is the reciprocal of this. And if I multiply both sides by negative 1 over 2, on the left-hand side, these just cancel. I get negative 2 over negative 2, or 2 over 2, which is 1. On the right-hand side, these multiply, I get negative 1/4. And that's my answer. Overall, this would look like this: negative 1/4, negative 1/2, and 1/2. Nice. Here's a good question for you. Would you say this system of equations is consistent or inconsistent? I got a few voices that say consistent. Want to cast it aside and vote? Consistent or inconsistent? Consistent, good. Why is it consistent? It has a solution. Just has to have one solution and it's consistent. So it's a nice consistent system of equations. These are going to be different equations, so it's going to be consistent, independent. I'm not going to be as big on the independent and dependent stuff, but we will see it from here and there. But looking good. There's your system of equations. Or there's your solution to your system equation. How could you check it if you're like, I'm just not feeling good about that? If you weren't sure about that system of equations or your solution, how could you check it? What if it works in one equation? Does that guarantee that it works? That it's a solution for all three? Yeah, it has to work in all three equations in order for it to be a solution. So if you are going to take the time to check it, probably try and check it in three equations. But checking at least one is better than nothing. So it should work in those equations. Let's move on down to example F. Any other comments or thoughts on example E here? Let's solve for example F. We're going to start by figuring out the augmented matrix here. Sade, I don't think I've picked on you yet today. What's the augmented matrix for this one, please?
1, 2, -1, 15.
Good, keep going.
2, 3, -4, 31. 3, 6, -3, 46.
Nice, well done. Now sometimes, depending on the author or the book or the website, they'll put a little dashed line in here to let you know that this is the right-hand side and this is the coefficient on the left-hand side. I generally don't bother with that. You can if you'd like. If it helps you remember what's what, that's fine. Let's exit out of here and enter our matrix. So I want to edit this. It's going to be a 3x4. We already know that. So let's type in these numbers. 1, 2, -1, 15, 2, 3, -4, 31. Come that 31 didn't print. 31, 3, 6, -3, and 46. Nice. Exit by second and then the mode key. Let's clear this out and take a look back at our matrix. Make sure it looks like what we expect it to. Okay, looking pretty good. Let's see about putting this in the upper triangular form that we've done with these other few. Program row ops. Why don't you help me out here? What kind of steps should we go through? Come on, the camera's rolling. Make me look good. Ellie?
Could we use row 1 and multiply it by -3 and add it to row 3?
Mm-hmm.
Or no?
Yeah. Just to kind of work in order, I'm going to get rid of the coefficient of x in the second equation before I do that. So I'll multiply by row 1 by -2. But yeah, we're going to do both of them. So let me copy down the matrix here. 1, 2, negative 1, 15. 2, 3, negative 4, 31. So what I'm going to do is just kind of log all the different commands that we're going to do. First of all, we're going to take negative 2 times row 1 and add it to row 2. And then I'm going to take negative 3 times row 1 and add it to row 3 per Ellie's suggestion. So we'll do both of those. Press the enter. First one I want to choose is option number 4, multiply row 1 by negative 2, add it to row 2. And then I'll do likewise with row 3. Let's get rid of the coefficient of x from row 3. Option 4, multiply row 1 again. Notice you're using that row twice. By negative 3, add it to row 3, and bam. Well, that's kind of interesting. Well, we succeeded in getting some zeros here, right? So let's copy down this matrix then. What matrix does that tell us? Well, let's see. We've got the 1, 2, negative 1, 15, 0, negative 1, negative 2, 1, and then 0, 0, 0, 1. So we did our couple quick commands, and then we got that. So you don't have to show me all the intermediate matrices, just write me down your commands, that's fine. Let's go back to the system equations. That's x plus 2y minus z equals 15. Minus y minus 2z equals 1. Elizabeth, maybe you can help me. What's that? Almost. How many z's do I have? 0. So what would this equation represent then? Yeah, thank you. 0 equals 1. 0 equals 1. Yeah, I don't know. Was I asleep that day in graduate school when they taught us 0 equals 1? Yeah. I'm thinking something's wrong.
That's close. So this way.
Oh, well done. Thank you. This is false. Notice all the variables dropped out, but you got a false statement. That's telling you that something's wrong. That this system of equations doesn't have a solution. If it doesn't have a solution, what do we call those systems of equations? Inconsistent. So if you get something that's false, then you know that, okay, you've got an inconsistent system of equations. Something in that geometry that we talked about at the start of this is going on. These three planes just don't all meet at a point. And you have to putz around a little bit to figure out, well, what's going on with the geometry, but it's enough to know that they don't meet at a point. Yes, ma'am?
WebAssign, they don't like inconsistent. You have to put no solution.
Oh, yeah. Yeah. No solution for the picky, hashtag, @ of WebAssign. Yeah. Inconsistent would be fine for me. So thank you for clarifying that. No solution for people at WebAssign. Okay. Let's move down to the next one, example G here. And let me just copy down the augmented matrix for that one. Example G. So in this case, it's going to be 1, 1, negative 1, 0, 1, 2, negative 3, negative 1, and 2, 3, negative 4, and negative 1. There's our augmented matrix. We'll start by plugging that in. So let's bring back our calculator. We've got to exit the program. I don't know about you, but I left mine hanging. We want to edit this matrix. Are you guys getting pretty comfortable editing matrices? Oops. Okay, so, well, here's the help. Second matrix, you want to go over to edit first and then select matrix A. So I always use the left arrow, then press enter. 3 rows and 4 columns. And then just start typing in your numbers. 1, 1, negative 1, 0, 1, 2, negative 3, negative 1, 2, 3, negative 4, and negative 1. Let's exit out of here. Second quit. And then I like to just print it real quick and double check that I've entered the correct system of equations, correct augmented matrix. Looking pretty good there. Let me take a quick pass out here. If there's somebody that's struggling getting that matrix in or something like that, flag them down. Go over here, show me up. Say. Thank you. Yeah, sorry, but I just don't have the cord that allows me to put that on the 83. It'd work, but I just don't have a cord for that. So, yeah, there you go. Bless you. All right, so let's run program row ops for this particular problem then. Program, enter, enter, enter. Select matrix A. What do we want to do to try and put this in that nice form that we've kind of headed towards in these previous problems? What's the first step? Want to get a 0 here, and then here, and then here, etc. What's our first step?
You could multiply row 1 by -1 and then add it to row 2.
Yeah, -1 times row 1 plus row 2. It's very helpful for me to see this from you. It's a lot easier to grade than watching you do this stuff by hand. So let's do that. So choose option number 4. Multiply row 1 by -1 and add it to row 2. Looks great. Let's see about getting this into that upper triangular form. So the next step Robert suggested was to multiply this by -2 and add it to here. All right, so let's do that. So let's multiply row 1 by -2, add it to row 3 this time. And all right, looking good there. So that was -2 times row 1 added to row 3. What am I going to do in this last one? What's going to get the 0 that I need right there?
Multiply row 2 by -1.
Yes. Multiply row 2 by -1, add it to row 3. Funny, Josh, I was thinking I should call on you, so you must have been reading my mind. So -1 times row 2 added to row 3. And I don't know, is something interesting happening when we do that? So multiply row 2 by -1, add it to row 3. And wow. Well, let's see, we get 1, 1, -1, 0, 0, 1, -2, negative 1, 0, 0, 0, 0. What's that saying about my system of equations?
Z equals T.
Not yet. We'll get there. Well, let's assign x plus y plus, minus z equals 0. And then y minus 2z equals negative 1. What's this last equation saying? 0 equals 0, which is kind of strange. But is 0 equals 0, is that true? It's true. So what do you think this says overall about our system of equations? It's consistent, but dependent. You've got an infinite number of solutions. Basically what's happening is that your three planes meet along a line, like case B right here. So you've got an infinite number of solutions. Now, if that's the case, you're going to have to do a little bit more work. This is no longer intermediate algebra, it's college algebra. So you're going to have to go a little bit farther here. So what's that extra work going to look like? Well, let's see here. You've got x plus y minus z equals 0. And then over here, for that second equation, gives us a chance to solve for y. Let me move the z to the right-hand side. The z term, I should say. That gives me y equals 2z. Okay, great.
Wait, isn't it negative 1 and not 0?
Oh, is it negative 1? Oh, yeah, I'm sorry. Equals negative 1 there. All right, so it's 2z minus 1. Thank you. Negative 1. Okay. If that's true, now that we know what y is, I can take that and plug it into the top equation up here. And then I'm going to solve for x. So it's going to be x plus this minus z equals 0. So let's plug that in. 2z minus 1. And solve for x. So all I did is I solved for y from this equation. I'm going to plug that in here. And that's going to give me, well, if I combine like terms, I get x plus z minus 1 equals 0. If I move these to the other side, what do I get for x? Negative z plus 1. Nice. So now I've got solutions for x. I've got solutions for y, and z is just kind of whatever. Overall, my solution is x, y, and z, but I can write everything in terms of z. So you could write negative z plus 1 instead of x, and y was 2z plus, or 2z minus 1, and z is just whatever. Once you choose z, then you get your other coordinates. Now, what if they want you to write it as a function of t? So, depending on t, that'd be negative t plus 1, 2t minus 1, and t. Doesn't matter what variable you use there. I think WebAssign does ask you to use t or sometimes s.
It's
T?
mainly T.
Is it mainly t?
I
Okay.
haven't seen one with an S, but that's not
Okay.
to say that it's not.
You can choose any letter you want here, but on the test it's good enough to solve it in terms of z. Now you could actually play this game with any variable. You could solve for everything in terms of y. and then have, you know, something in terms of y, something in terms of y, and then y. So it doesn't really matter. WebAssign should take it all. They'll be equivalent. But this is the parametric form of your equation. It's what we saw in section 10.2 when we looked at, where was it? Looked at a graph like these two, where the solution was really an infinite number of points that are on the same line, and you parameterize that, and then you can just choose whatever value of s will give you whatever value of y that you want based on your value of s. So you can get anything, and you're parameterizing that to basically trace out the line in 3 dimensions. Okay, looking pretty good here. Let's see. Comments or thoughts on this last one here? Let me give you a little chance to practice that kind of thing here, putting these into a parametric system of equations. So, for instance, example H, let's see, do I want to play with that? Example H, if you do all this elimination stuff, what you'll end up with is this system of equations. You start out with the 1, the 2, excuse me, the 1,
-2.
yeah, never mind. You know what, we're going to have to maybe do this one out. 1, -2, 1, 9, 2, -5, 6, 19, 2, -3, -2, and 17. So that's what we're going to have to put into our calculators for this one. And we're going to get another example of a dependent system of equations. And let's see what that gives us. So let me exit out of here. Let's plug in that matrix. So go over to edit. It's still a 3x4. 1, -2, 1, and 9. 2, -5, 6, and 19. 2, -3, -2, and 17. Let's exit out of there and then double check our matrix. How are we looking on that matrix? Got that one entered in? Not yet? Okay. I'll give you a few more seconds. All right, so let's run program row ops here real quick. Let's see what happens with this one. Program row ops, select matrix A. What are some of the steps we're going to do to put this in that right form that we like? What will be something that you see? I think we'll start with -2 times row 1. Added where? Row 2. And we can also do -2 times row 2 added to row, or actually -2 times row 1 added to row 3. So we can do that similar command twice. multiply row 1 by negative 2, added to row 2, and then multiply row 1 by negative 2 again, this time add it to row 3. So we're looking pretty good here. And then we need to get this one last 0. I need to get this to be a 0. You can just add these two rows, but out of habit, we're going to just do multiply row 2 by 1 and add it to row 3.
Could we do on the calculator operation number 2?
Let me look back at what that is. Probably, but let me look back at what that is. So yeah, operation 2 I think just adds a row from one row to another row. So you could do that. Just out of habit, I always just use the fourth one. Multiply row 2 by 1, add it to row 3. And what you see is another dependent system of equations. You're getting something like what we got earlier. 1, negative 2, 1, 9. 0, negative 1, 4, 1. And then 0, 0, 0, 0. That represents a nice augmented matrix. But when you get a row of zeros, that's screaming out you've got a dependent system. Dependent. Now let's look at this system of equations. What's this second one saying? Saying negative y plus z equals 1. So let me do that up here.
Plus 4z.
Thank you. Negative y plus 4z equals 1. If I want to get y by itself, I can move the 4z to the right-hand side and divide by negative 1.
Or you can just add y and subtract 1.
Yeah, I like moving the y over here and subtracting 1 over here and get 4z minus 1 equals y. So that's my expression for y. We're going to need to plug that into the equation for x. X minus 2 times y plus z equals 9. And z was 4z minus, or y was 4z minus 1. X minus 8z plus 2 plus z equals 9. Yeah, that looks right. If you combine like terms, we end up with x minus 7z plus 2 equals 9. Subtract 2 from both sides, add 7z to both sides. I believe I'm going to end up with x equals 7z plus 7. Is that what you guys are getting?
Yeah.
All right, thank you. So we got x in terms of z, y in terms of z, and then z. Your final solution should look like this. 7z plus 7, 4z minus 1, and z. There's your system. There's your solution. It's parameterized, and I would expect to do a parameterized solution on the exam. Whew. All right, I do kind of want to finish up here. I know that I'm going much longer than I usually do, and I apologize for that. Let's look at example 1. All I want to do for you in this one is set up the system of equations. Maybe we'll work on example J together. Example K we can kind of work out as well, or at least figure out what you do. I think we'll skip example K here for the time being. Mark has $100,000 to invest. His advisors advise him to diversify his investment in 3 types of bonds. short term, intermediate term, and long term. So I'm going to use S, N for intermediate, and L for long term. Now, if we're going to solve a system of equations, typically speaking, you have to have an even number of equations and unknowns. So this whole chapter started with something like this, where we had what's called a 3x3 systems. When you're solving something like that, the first 3 represents the number of equations. So 3 equations. And the second one represents the number of unknowns, 3 unknowns. In order to have a good chance of solving, these 2 numbers have to match. You have to have at least as many equations as you do unknowns. So in this particular example, our 3 unknowns are how much you're going to invest in bonds, short-term bonds, intermediate-term bonds, and long-term bonds. Well, that's answered right here. You've got $100,000 to invest. So $100,000, that's going to be the total of your short term plus intermediate term plus long term is $100,000. So there's the first equation. The short-term bonds pay 5%, the intermediate pays 6%, and the long-term pay 8%. Mark wishes to realize total annual income of 6.5%. Okay, so that's another equation right here. So how much money is he getting? Well, 5% of whatever you invest here, that's going to be coming back to in terms of income. So I'm trying to color code these things for you, so if you look back at the notes, that you'll see, well, where did this equation come from? It's coming from what I have highlighted here. So 5%, 0.05S plus 0.06N plus 0.08L, that's how much money he's getting in interest. And he wants to make overall 6.5% interest on his money. So that's going to equal 0.065 times his $100,000. 2 down, 1 to go. And the last one's kind of hidden a little bit. It says with equal amounts invested in short-term and intermediate term. Can anyone tell me the equation that represents? Yeah. Short term equals intermediate term. So there's your 3 equations. Now you clean that up. If you wanted to, you multiply this times this, you get 6,500. And then you can multiply the whole equation by 100 to clear up the decimals, etc. But there's your system of equations right there. So if you're stuck solving one like this in the homework, which I think you might, that's what you would probably want to do. Okay, let me give you a chance to work on one. I'll walk around and help out. It's going to be this one. Start by plugging in the augmented matrix. -1, 2, 5, and 1. 1, 0, -2, 0. 4, -2, -11, and 6. See what you come up with this one. Remember, you want to get the zeros here in this order, this one, and this one. home, and it just feels like a direct translation. It doesn't feel like something they've actually
I
said.
use it all the time.
Do you?
Yeah.
Do you? Okay, all right, well, that's good to know. All right.
No, I'm not sure if the move I need to make this too.
Okay, well, you got a 0 here.
Yeah.
What would make that a 0 there?
Can they cancel out first or no?
You want to multiply something and add it to another row.
Oh, it's from the first one. Okay.
Yeah, so,
I got confused. I was trying to do something to this row.
So what did you from here? I saw that again first.
oh, we want to do 0 here. So what do you multiply this by to make that a 0?
Well, there should be 2, the 6 should be 0, right?
Right, so you want to get this to be a 0.
Yeah, so I can multiply this at 1 over 9. Yeah. And then add it to row 3 or whatever?
Exactly.
Okay.
Okay. Actually, I think I'll do this one on my calculator here. Let me just double check that I've got this entered. Second matrix. Try again. Uh-oh. Second matrix. Yeah, that looks like the right one. So let's play around with row ops right on my calculator. Run program row ops. I want to select matrix A. First thing I want to do is I want to get rid of the 1 here. So I can just add row 1 and row 2. I'm just going to always do it this way. Multiply row 1 by 1, add it to row 2. And then I want to do that again to get rid of the 4 here. Ola, what'd you do to get rid of the 4 there?
Oh, well, I multiplied row 1 by 1 and added it to the second row.
Okay, want to get a 0 down there as well?
Oh,
And the four-
because I
or the
messed
fours?
up the first one.
It's all right.
So I multiplied the first row by, I was thinking 4 to make it negative 4.
Perfect. So multiply row 1 by 4, add it to row 3, and we get a 0 there. Nice. Let's see. Elise, I need to get a 0 here. What can I do to get a 0 where that 6 is? What times 2 would make that a 0 added to here? So negative 3 times 2 would be negative 6, added to 6 would be 0. Okay? So multiply row add, so it's going to be a 4. Multiply row 2 by negative 3, add it to row 3, and wow. So we end up with this after all that work. I probably should have written down my commands along the way, but I end up with this system of equations: negative 1, 2, 5, 1, 0, 2, 3, and 1, 0, 0, 0, and 7. What's that last equation telling me?
0 equals 7.
0 equals 7. What do you guys think about that? Does 0 equal 7? False. Inconsistent, or as WebAssign would say, no solution. Nice. Nice. Whew. All right. I think we've spent a lot of time on this section. So, yeah. Any other comments or thoughts on this one? Nikki, did you get the solution to this one?
I think so.
What'd you get?
I have 30,000, 30,000, and 40,000.
Let's say that would be N would be 30 pounds. And then long would be 40,000. Nice. That checks in a bunch of ways. First of all, S equals N, so that's good. The total of these is 100,000, so that's good. you can check it in here, and what you'd end up with is $6,500 in income if you put it in this equation. So, yeah, looks good. Well done, sir. Thank you so much. All right, I think you guys deserve a break.